Hey guys, it's Rena, and today we're going to be doing lesson 2.13, and today's special guest is...
Hi guys, I'm Chelsea. If you don't know me, I'm a junior and I'm in Calc AB right now. So let's do this.
Okay, I'll be starting off with some notes, so let's get started. Okay, so today we're going to be going over exponential and logarithmic equations and inequalities. But before we start, I do want to go over some log rules just for review. So if you have two logs with the same base, so let's say we have log base a of x plus log base a of y. If you're adding two logs with the same base, that's also the same thing as log with that same base a of x times y. So if you ever see log base a of, or log base something of two numbers multiplied, you can also break that down to log that base times the two numbers separate and use them interchangeably. So that makes it a bit easier. You can actually apply it here, but we'll get to that later. Another rule can be, let's say we have log base a again of x, but it's minus log base a of y. You see it, they both have the same base, but this can be the same thing as log base a of x over y. So that's just another thing you can apply. Subtraction, you can substitute it for technically division, and then whenever you're adding them, you substitute it for multiplication. And then the last rule can be with exponents. So let's say it's log base a of m to the power of k. You just take the exponent and put it in front. So that's the same thing as k log a of m. So these are just things you have to memorize, and it'll be a lot easier for you to break down problems, but just keep these in the back of your mind. You can take a note of this, or take a screenshot, but we're going to move on for now. We can move on to this problem. You see right here that they both have the same base, and you're adding them, which means we can use that first rule that we went over and multiply whatever's in the parentheses. So log base 3 of x times x plus 7 equals log base 3 of 60. And because both sides of the equation have log base 3 in it, you can just kind of discard that and just look at the x times x plus 7. Don't know why I wrote it like that. Equals 60. And then you can distribute. So x squared plus 7x equals 60. Then you can subtract by 60 on both sides so that you can get them all to one side. X squared plus 7x minus 60 equals 0. And now it's just factoring, so we're thinking what two numbers multiply to negative 60 and add to 7. And those two numbers would be negative 5 and 12. So x minus 5 times x plus 12 equals 0. And now you want to set each of these equal to 0. So you can move over here, x minus 5 equals 0, so x equals 5. And then x plus 12 equals 0, so x equals negative 12. So these are both contenders. And now I can plug them back into this original equation. So let's start with 12. Log base 3 of negative 12. We can go ahead and stop there. We don't have to continue because we know that there can't be a negative in the parentheses. So we can go ahead and discard this answer choice. Now let's plug in 5. Log base 3 of 5 plus log base 3 of 12, since x is 5 in this case, and 5 plus 7 is 12. Log base 3 of 12 equals log base 3 of 60. And now remember, since they both have the same base and that we were adding them, we can multiply whatever's in the parentheses, and 5 times 12 is 60. So log base 3 of 60 is equal to log base 3 of 60, which is true. So it would be this answer choice right here. Okay, now here we're essentially doing the same thing, except now we have constants, so it gets a little bit more complicated, but here we see that both of these logs have the same base of 2. So let's just get all of those to one side first. So we can add log base 2 of x plus 7 on both sides. And now we have 3 equals log base 2 of 5 plus log base 2 of x plus 7. And using that rule, we can just combine these two since they have the same base. So 3 equals log base 2 of 5 times x plus 7. We can simplify that even more by distributing that 5 to the x and the 7. So 3 equals log base 2 of 5x plus 35. Now we can apply just basic log properties where we take the base and put it to the power of whatever the equation equals, and that should equal whatever's in parentheses. So 2 to the power of 3, let's move over here actually. 2 to the power of 3 equals whatever's in that parentheses, so 5x plus 35. To the power of 3 is 8. 5x plus 35. Then we can subtract 35 on both sides to get x alone. So negative 27. I'm not good at quick math. Yes, negative 27 equals 5x. We can divide by both sides to get x alone completely. So x equals negative 27 over 5. That's our only answer choice, so I'll trust it to be correct, but you can plug it back into that original equation just to check. Okay, now we're actually going to be applying logs to solve exponents. So here you can see that both sides can be divided by 3, just to make the problem a bit easier for us and less intimidating. So now it's 2 to the power of x plus 2 equals 4. So now we have a better view of what this looks like. Now we can apply a log to both sides, and we're going to take the base from the base of our original equation right here, which is 2. So we're going to do log base 2 of 2 to the power of x plus 2 equals log base 2 of 4. So log base 2 of 2 to the power of x plus 2 is just x plus 2. You're just going to look at the exponent in the base. And then log 2 of 4 is just 2, since 2 squared is 4. So now we can take 2 away from both sides, and we know that x equals here. So really you're just taking the log with the base of whatever's in that equation, and the answer for that part of the equation will just be the exponent that's in the parentheses. Okay, now for this next problem, it's kind of hard for me to show you, but you just want to plug in this as a function in your equation, and this as a point, and you're just going to check where they intersect, and it'll be at x equals negative 5.9. But that's your answer. That one doesn't take much effort, as long as you know how to use your calculator, which I don't. Okay, now for these, let's start off with this one. You just have to remember that ln, or natural log, is equal to log base e of whatever. Those are the same thing. So here, really, we're looking at log base e of square root of x minus 12 equals 4. So if we apply just basic log rules, e to the power of 4, or principles, equals square root of x minus 12. And to get rid of a square root, you can just square both sides. So e to the power of 8 equals x minus 12. So you can add 12 to both sides. 12 plus e to the power of 8 equals x. And you can leave it at that, or you can put it in your calculator. That's your answer. Alright, and that's it for the lesson portion. I'm going to hand it off to Chelsea for some extra practice.
Okay, we're going to start with number 2, because I feel like number 1 is pretty self-explanatory. So, anytime you're doing something e to the power, you're always going to use ln, because that is like the complete opposite of it. So, you'll like cross out, in other words. So, you're going to do in, and then e to the power of negative x equals in. So you just multiply ln. You'll just multiply both sides by ln. And then when you have that, the e and the ln will just cross out because they're complete opposites. So it'll just be negative x equals ln 3.65. And then you'll bring the negative or the -1 to the other side. So it'll just be x equals negative ln 3.65. And that is about, if you plug it into your calculator, negative 1.295. Perfect. If you can see that now. Okay, now we're going to do number 3. So, with problems like these, if the log has the same number below, or in this case doesn't have one because the 10 is implied, you can just take out the log and then it'll just leave you with whatever's in the parentheses. So, you're going to take out the log and do log, and then in parentheses x times x minus 3, because now you've taken the log out of both this part and this part, and then that'll leave you with just what's in the parentheses, so you can take that out. And when you multiply those two together, it'll be log x squared minus 3x equals 1. And when you don't have a specified number on the bottom, it's always going to be 10 for logs. So you can assume that 10 to the power of 1 is just 10, because anything to the power of 1 is itself. So you can make that x squared minus 3x equals 10. And then you're going to bring that to the other side. So x squared minus 3x minus 10. That's going to give you x minus 5, we'll put these in parentheses, and x plus 10. If that doesn't make sense, I always use the trick where you do a little x, and then you put the last variable on the top, so negative 10, and then negative 3 would be on the bottom, and something that multiplies to negative 10 and adds to negative 3 is negative 5 and 2. So that's just like the process in my brain that I always do for that. So your answers would be x equals 5, and then it might trick you because you'd think that it could be x equals negative 2, but regarding logs, you cannot have something that's a negative. So x equals negative 2 would not work. So your only answer is x equals 5. And now we're going to do number 4, but number 3 for us. 80e to the power of 0.045x equals 240. So we'll scroll down just in case y'all can't see that. We're going to start with dividing both sides by 80, because that is the first step when you have a variable in front. So we're going to divide both sides. That's going to get you just e to the power of 0.045x on the left, and then on the right, that's going to get you 3. And then from there, you're going to do the same process that you did for number 2, or the first problem that we did, and you're going to put the ln to make sure that the ln and the e cross out. So that's going to be ln e to the power of 0.045x. And then on the right side, you're going to have ln 3. And then from there, this is going to cross out. So you're going to have 0.045x equals ln 3. And you can now divide both sides by 0.045. Just went completely through, but you know where my process is coming from. And then that's going to leave you with x, scroll up a little bit, x equals ln 3 divided by 0.045, which, if you plug that into a calculator, is going to get you about 24.414. Alrighty.
Hi again, I'll be continuing on where Chelsea left off. So let's start off with this problem right here. Log base 3 of 5 minus 2x equals log base 3 of 3x plus 1. So here, since they both have the same base, we can just look at whatever's in the parentheses. So 5 minus 2x equals 3x plus 1. And we just want to bring it all to the same side, or all the x's to the same side at least. So we can add 2x to both sides. So we have 5 equals 5x plus 1. We can subtract 1 on both sides, so we have 4 equals 5x. Then just divide both sides by 5, so x equals 4 over 5. Okay, now for this next one, we see 3 minus log base 4 of x plus 3 equals 5. So the first thing I'm going to do is get rid of this constant, so I'm going to take 3 from both sides. So now we have negative log base 4 of x plus 3 equals 2. Then I'm going to divide both sides of the equation by negative 1 to get this negative out of the log. So now we have log base 4 of x plus 3 equals negative 2. And now we can just apply basic log principles. So we're going to take the base here and raise it to the power of whatever the equation equals, and it should equal whatever's in the parentheses. So 4 to the power of negative 2 equals x plus 3. Whenever you're raised to a negative power, you're going to take the reciprocal, you're going to put it below the numerator, but you're going to keep that exponent, so it's going to be 1 over 4 squared, which is just 1 over 16. So we're going to go back to this over here. 1 over 16 equals x plus 3. And you can take 3 from both sides, so x will equal 1 over 16 minus 3. And you can put that in your calculator to get a number, but it'll be really uneven, so you can leave it like that if you'd like. Okay, now I know this next one might look a bit intimidating, but we're just going to start off with looking at the right side of the equation. And if you recall from earlier, we learned a rule that if we see two logs with the same bases that are being subtracted from each other, we can just substitute that for that same log with the same base, except which here it's log e, except now we can put this first set of parentheses in the numerator and put the second set in the denominator. So what we just wrote down is equal to the right side of the equation. It's just a condensed way of seeing it, so it'll make it easier for us to solve it. So now we can put that natural log of 12 back in. And remember, if we see two logs and they both have the same bases, you can honestly just ignore them whenever they're on the opposite sides of the equation. So you can just take whatever's in the parentheses, which here it's 12, and then 2x plus 3 over x minus 4. So we're going to take that out so that we can solve for x. Now you're going to multiply both sides by x minus 4 to get it out of the denominator. And you distribute the 12 to the x and the negative 4, so 12 times x is 12x. 12 times negative 4 is negative 48. And that all equals 2x plus 3. And now remember, you want to get all of your x's to one side and all of your constants to one side. So I'm going to take 2x from both sides, so we have 10x minus 48 equals 3. And then I'm going to add 48 to both sides, so 10 equals 51. I'm going to divide both, 10x equals 51. And you can divide both sides by 10, so x equals 5.1. And that is your answer. Okay, now for this next one, I'm going to take 68 from both sides to get all the constants to one side. So e to the power of 2x minus 1 equals 139. And now we're going to take natural log of both sides, because natural log is log e. And if we take log e of e to the power of 2x minus 1, it'll just equal 2x minus 1. So if we take natural log of both sides, it'll equal 2x minus 1 equals natural log of 139. And then you can add 1 to both sides, because remember, we're trying to solve for x. So 2x equals natural log of 139 plus 1. You can divide both sides by 2. So your final answer is x equals natural log of 139 plus 1 over 2. Now, obviously, if you put that into a calculator, it'd be a much prettier answer, but that's it. And that would be the end of today's lesson. I'm sorry that it was broken up into so many parts. But yeah, as always, check the comments below for the extra review notes and study guide keys so that you can have enough practice for your test. But yeah, good luck and happy early holidays.